clone, you know? But the problem with a mutable clone and why stores are important here is a mutable clone doesn't pass through. What do I mean by pass through? I mean, if you use a store as your source, you should be able to have the outgoing projection also update when the store updates. See, one of the benefits of this write method was that if we go back to when this thing was just a store, you know, like forget all about this, and we go back to when this thing was a store. If our store also has B and C on it, okay? If you listen to proj B, you know, like an effect or some rendering or something, even though, like let's pretend this is tied to some kind of signal. It has nothing to do with this projection it's doing, right? A is overriding this value or something, right? Or setting this value. But so if the store updates B, like someone here calls set store update B, it should still update through the projection, right? Like you over, and it shouldn't even need to run the projection if you think about it, because it didn't read from B. So how could it possibly run the projection? Conceptually, I'm still on the fence whether push pull is actually just better for the client, but where it sits, it looks like that. Yeah, it's not entering the scope, right? Like there's nothing here that's listening to store B, right? So this should still work. And the problem with immutable cloning is the store can't be the source anymore because you've cloned it. Like it's not, if you cloned it, and I guess you cloned it in here, then you could re-trigger this whole thing and then recreate it and go, but you get, this should just work. You should be able to, you know, let's continue on here for a minute. Yeah, I talk about the whole reconcile problem. This is I was saying that it was create async and reconcile, but we actually, with optimistic updates, we actually have a pattern where we reconcile when the list comes back from the server, and then we fine-grain add on the mutation. And this pattern is the most optimal way that exists. You can't even do this in React because you have to clone everything and re-render the list and diff everything. This is like, it turns optimistic updates to the same performance level as normal signal updates on the client, like just like one for one. And then the diff should in concept match, which should cause no further updates. It does do a diff in the background, but it means that the actual, from the UI standpoint, it's the whole server interaction is basically as optimal as if it was client only. Like we changed the physics of it because client update. So you go, oh, I'm going to add a new to-do. So you tell the server you're going to add a new to-do. And then the client just adds the to-do into the list, into the projection over the server data. So you have the server data plus the to-do. And then the server comes back with the updated full list of to-dos. Like I'm picturing something like TanStack. Like it doesn't have to, and you call it a day, but if you want to have a model that actually stays up to date, you know, maybe someone else pushed something while you're gone. Well, conceptually, if no one has, the list that comes back from the server has that new to-do in it, and the IDs match and the keys match. And because of stable references that come from the projection, it means that you actually don't recreate the to-do. It just goes, okay, yeah, everything matches, I'm done. So like the only actual mutation that made its way to the DOM was the initial fine-grained update. So where you updated the to complete. So like, or added the to-do or whatever. So like this model is incredibly powerful because it doesn't clone, doesn't remake, it doesn't do anything. It literally just, you know, it lets you use something like a TanStack invalidation model, yet be completely fine-grained. Now, as I said, the problem was that we were writing to create the async data and we're mutating it directly, right? So yeah, signal source. And then, so I was like, what about this idea of pass-through, right? What if we could, this is where I got source guarding from, because I was like, what if we could essentially have the original data, and anything that the projection didn't override pass through. So we'd keep a source and an override, right? And then I talk about resetting and reconciling and better mapping. And I go on a crazy tangent where I actually decided, I was like, well, what if we just diffed every time you assigned, but then you change the semantics and stuff. Let me see if I got any conclusions here. But yeah, I talk about mapping because a lot of times people want to map. Yeah. Yeah. See, I guess one of the problems here is if you're not, projections lend to diffing. Like, don't get me wrong, you could, or applying diffs, because you could describe the next state, um, like the way that I'm like doing here, like describing the next state, but it's quite often what you actually happen is you added a to, or you did a specific event and you only want to do the specific action. You end up with that switch statement, a bit like that switch statement we saw in Signia, if you think about it. And I was like, well, can we get back to that niceness that we have with I call it niceness, but it's a lot of cloning that we have with like immutable data, where you just need to describe the next data source, right? And the answer to that is tricky. I went through this whole thing where I was talking about preserving state and auto resetting and auto. Basically, I'm going to go to the next article because I think I'm done on this. And the answer kind of is no. Rethink protection and pass-through protections. Let's go to this article. Sorry. This is where I go through all the academic stuff really quick before I get to the actual demo. Right. So I was like, okay, this whole article here was like, what if there was no reconcile and it just everything automatically reconciled? So I was like, I started playing it like an example, right? Where you have a signal with an object in it, and what's cool about this is you don't call reconcile. Literally, anytime you assign a signal or value to a store, you just get fine-grained updates out the other side. Sounds pretty sweet, right? If you set a new object here, both of these will update. One will, right, causes P1 and P2 to rerun, and also triggers, everything because it diffs. But it doesn't trigger A because A didn't change, right? Only B changed, 2 to 3, right? Consistency protection makes a memo around the read-only value. So basically what I started realizing is, don't view, in the way that we view a store as a tree of signals, we should view a projection as a tree of linked signals, using the Angular term, or I call them writable memos, right? Like, this is what people think they want, but I realize this is what they don't want. We'll get there. Like, it's close, but there's problems here, which we'll get to. And then I was like, okay, well, can we do the same thing with what did I say? Store object source. What did I do that? What's this one? Simple object stores. Yeah, I'm like, now what's the difference if it's a store? Well, if it's a store, when we set B to 3, we're doing a fine-grained update now. We're not like replacing the whole object. Technically, this one doesn't need to rerun because this store is still assigned here. But this one does object.assign, so it actually accesses like s.a, s.b. So this will trigger it to rerun. And it triggers and doesn't trigger. Same behavior, right? The only difference is now, because you're using a store, it's actually smart enough and you're only updating the thing, not to rerun the projection in this case, only in this case. Okay. And then I go on a whole thing about solutions using writable memos anyways. It doesn't actually work that way. It's actually more complicated than that. Signal array source. Same idea. Honestly, this isn't rocket science in terms of what the expectation is in terms of like diffing. But the problem that I started having was I started playing around. Yeah, okay, I started around moving items around, and I pointed out that the operations were actually kind of expensive here, because you actually have to look in the array the challenge here with arrays of objects is that like it's the same problem I mentioned before with React. If it matches on the model, it still has to diff deeper, which means that like every time you move something around, even if nothing changed, it has to diff. And this is sorting to get around. I started kind of playing around with trying to design the solution, array overrides. As I said, if you want to go into it, you can. But like you have to understand that there's a lot of operations that don't care to diff the list. Yeah, if you send an array, you have to diff the list. But if you push, then you're adding an item on the end. And it's kind of interesting. The problem that you have is like a shift operation, put something at the front, which means that the proxy gets like some people ask why we still use array assignment in solid instead of using like push or like why we don't recommend push and stuff. And the reason is push is fine because it's at the end and you can just assign at the end. But when you use something like shift or unshift that moves the front, the proxy actually triggers on every single index in the array with the new value. Now, honestly, it's probably not that bad. I just was like focusing because our API was immutable, just to keep it that way. There's no real cost, works fine the JS framework benchmark, etc. But if you were shifting and then getting a new index and then you have to diff every time against to make sure, oh, is it still in the list? Or like it doesn't know what it's getting. So every index would have to diff arguably independently against the whole rest of the list to figure out like, okay, am I a known model? Should I diff further? Am I a replacement? Do I need to wrap? Really bad for performance. When and I was really trying to push this, get rid of branching. Like what if you could just make it this out of state? And where did I summarize it? Like I go through a bunch of problems here. I don't know if it's worth getting too deep in this, but essentially it doesn't really work. I started like talking about how the problem is like you naturally start asking conditionals and splitting the logic because like if it's not, I was thinking like, look, if you could every time the projection updated just reassign the to-dos and do the diff, that would be great because then now you don't have to worry about it. You could just go like, this is an example of adding like a selected index to to-do list. You could basically just go like every time the projection updates, diff the list, and then, if it's the same reference, you don't have to do a diff here, and then project the thing on. And like basically this way, if this updated, this would be a no op. And if this updated, then it actually did the diff. That was like my thinking. So then you could get rid of the conditionals. But what I realized is first, stores can update without triggering the top level. It's never going to show different. It's never going to show up different in a diff, same store reference. And if the underlying store updated super granularly, we will lose change. What if the mutation isn't selection, but instead something that overrides the base to-do list, like a temporary item, like an optimistic update? In that case, you wouldn't want a different change like selection to cause a reset, which it would. So like, there's a lot of, I'm hoping I'm making some sense, but there's a lot of edge cases that come with trying to just assume diffing. And it boils down, I got to a conclusion here. Yeah, I was talking about, okay, well, if one extreme we fall back to a diff and project the world, what's the other extreme look like? Well, ton of branching, right? Which is like what Signia is doing. But does this design lend to function forms of stores, projections? Okay, conclusion. I just need to make things so I can play with it. So takeaways. Projections shouldn't mutate their sources. Good. There may be a few solutions to this, but that's the core principles. Ideally, we want to restrict the range in which we diff, which can diff based on the type of operation we do. At the extremes, we either diff everything or communicate diffs in. It's questionable whether the middle needs to exist. Mutation pushes you into thinking in terms of discrete events instead of stabilized state. This is an important thing, right? Diffs. This is where I realized that diffs or instructions are events and not state. Okay, sorry. I'm getting to the last article now. I know this has been kind of a whirlwind, but we're getting there. Just going to post it in here in case people want to follow along. But this is after I did the proxy thing, right? And I started this mental thing. We've already established that these are the three qualities we want. But I got to this place by identifying that for stores, like let's look at this conceptually what stores are. Stores are writable versions of mutable reactive equivalent signals. They require stable reference, and if expression is, they are portable and the source of truth. So I was like, I Moscowed it. I'm like, okay, reference identity is a must, but that's the only must of stores. We should probably make it reconcilable, unless we were going to say that all diffing happened in projections. We could do path identity, like give an option so it works like Svelte, like where you needed like explicit models or IDs if you wanted to have that shared behavior. But we could source guard. Stores don't need to be source guarded because you can just mutate. Like we've been getting away with it in Solid and Vue for years, so it's fine. But you probably wouldn't want to reconcile on write, like diff on write. Projections should have reference identity, but must be reconcilable and must be source guarded. So I basically just looked at these and we're like, okay, must here, must here, must here. Those are the only things that we 100% need to do. And I started designing that. And that it's no surprise that is this list right here. Right. But then when I looked at the coulds, it was a lot harder. And honestly, I go into like talking about the trade-offs here and like whether like I think one of the biggest key things is like should stores and projections be the same, like core primitive? And I arrived at yes. For a while I was thinking, okay, they could have different rules, but it's confusing. If projections diff when you write and stores don't, like it creates weird expectations. And ultimately, I love in the same way that like I don't know if you've seen this, but in Solid 2.0, the idea is if you go set state, okay, and you go create signal, okay. If you pass a basic value or an object or whatever, it's just a normal signal. But if you pass a function that props data, now it's a linked signal essentially. Because I realized that the form of the setter is the form of the derived state. It actually takes previous as an argument. And what I want is that when you do create store, when you pass the function, like also you can pass the object, but when you pass the function, it's a writable projection. Thanks. Yeah. No, for me it was a big realization. Yeah. Does it track? Right? Like there's a parallel here, right? Why? Like, and for that to happen, you kind of need them to be the same primitive. Does it track destruction? No, I mean destructuring doesn't work in general because they're still functions. These are proxies. Yeah, I just give up on destructuring. It's not worth your effort. It actually makes code less clear, I think. Anyway. So because of this sort of parallelism, I'm kind of I don't think we should diverge. And basically the only cost is unwrap goes away. That's the biggest cost here. At least for the musts. So it comes down to the coulds. Do we want to diff all the time? And is it realistic or clunky to try and force models or collections? Because in order to diff all the time, like there's a reason that reconcile has IDs. You need to be able to like recognize when models are the same. I think so. Like it's not enough that like you can't rely only on referencing when you do diffing. So I go through a bunch of examples. It doesn't really matter that much. I'm trying to remember where I actually hit the thing. I used the JS framework benchmark. Yeah, this is fun. Because I was showing like, okay, what if we took a benchmark that's big on performance and tried to see if we diffed on all the operations, would there be an overhead that would be expensive? This is a pretty hard line to go against because I'm basically saying I don't think if we diffed always with stores, I don't think anyone should suffer the performance, right? That's basically the argument. So I'm like, okay, what would this look like? So I actually went in and like took the code from the JS framework benchmark and go, okay, we're going to add a 1,000 or 10,000 row. This is unchanged because if the list is empty, we basically bypass the diff because it's all new. Good. Okay, so it doesn't affect creation time. Replace 1,000 rows. The same code getting called as above, but the items are already in the list. In the benchmark, we know there are no repeats, so one could cheat by clearing before setting, but I think it goes against the spirit of the test. This unfortunately would lead to a shallow diff on the dataset. It would realize nothing is matched, but not before checking every item in case the nested item needs further diffing, and then it would diff again at the insert point. Basically, you'd both diff at the point of setting the data and then realize nothing had changed, or that it was all new, and then you'd have to actually diff the DOM to do the replacement. So this is probably one of the biggest wastes of time by defaulting to diffs that you don't get with just a replace. Update every 10th row. Sets a primitive value, so no diffing. Yeah, it just updates a string, so like there's no diffing. Select row. This uses a projection demand index independently, so no diffing. That's fine. Replace row. This works off an index switch that would shallow diff the items being switched. Since these are models, it would diff all the keys in the new location. This might have a tiny overhead, but this operation triggers list reconciliation anyways, and there are only 2 listened to properties, so this might be unnoticeable. Remove row. This one is actually pretty problematic. The proxy traps would see this as an index change for every item after the change. So it would independently diff each of those. If the keys lookup was global, this might be somewhat okay. So I'm saying is if you don't look in the array for the object, instead you have like some model map that's universal, like your IDs are universally like UUIDs. Like, so no, like you don't have a user with model 1 and a post with model 1. You have a user with ID U1 and a post with P1 or something like completely unique. This would be fine, but otherwise you're actually having to diff through, like look up in an array, which is like not an O to the 1, but an O to the n operation for each index impacted, which means it's an n squared operation, which is pretty much unacceptable here. Add 1,000 rows. Classically, we do this. It's more expensive than with diffing probably, so you probably just push. If we assume global keys, all new data, so lookup would be cheap with no diffing. But without global keys, this would also be expensive. Clear row is cheap from a diffing standpoint, so that's fine. So it's worth pointing out that none of these scenarios want data diffing. So the penalty on 2.5 and especially 6 would not be wanted. I could make an argument for maybe 2 if you viewed it as a filtered query case. But 5 and 6 are fine-grained operations and their intent doesn't carry diffing with them. The main reason is a proxy can't tell the difference between a move and a set. In fact, none of our semantics really can. A move doesn't require diffing unless it's also a data update, and we can't encode that information into a single mutation. This was the other huge mind-blowing thing for me to realize. I don't know if this is obvious to people, but I'm like, wait, no. I realized 2 seconds later that I wasn't 100% right, and I'll clarify that in a minute. But just think about it. Like, this is the reason why you lose information to mutability, because you put a bunch of changes in and you encode into the next state. Now you don't know what changed. The same thing can happen to mutable change if basically, like, it's fine if it's all updates, but if you have moves involved as well, you can't really tell what the intent is. You have to assume that anything moved could also be updated. Okay, no, wait, I'm wrong. There is a way to tell between set and move. A set has a previously non-proxied value, and a move would have an existing proxy value. So yes, case 5.6 would see a proxy and know not to diff. Splice still hits the proxy trap every index, but after the change. But this is a problem with mutable updates in general. With this knowledge, how bad is setting a new array if the items are proxied? Well, O to the n. It isn't free, but isn't necessarily super expensive. It might be enough that it's less preferential in like splice case to just hitting every index, which it is today. Also, case 2 is more expensive than I'd like, since it also needs to go through and realize none of the keys are actually matched. Well, it's good to know that there's shortcuts, at least here for performance. The only real cost here is a minimum of always distancing system is it'll be shallow checking every index of an array on set of a full array, which would otherwise wouldn't need to happen. There's a world where this cost probably isn't too bad on performance, and Magic allows it to be pretty compelling, right? And when I showed this original demo, you guys, like, I saw the thing in the chat being like, wow, this is sweet. So we could just easily just not diff in all these scenarios. At least I think so. We haven't really looked that deeply on maintaining source guards like this. There is a sort of diff like quality to that solution, and there may be some nice qualities for even localized explicit diffing. We make global models a concept. So I talk a bit about data structures here. Basically our store node, like the thing we proxy over, actually having a reference to the value, the override, and then the different types of signals like the get and in, because we have to actually handle the get case differently than the in case, and they have to be independently reactive. I'm not going to lie. This was really tricky to figure out, and none of the solutions I put here actually ended up working. Because the problem is, if a store override creates a signal, like we create signals on read, generally with store. So that's good because that means that anyone in the future who listens to it will get that update if it changes. So even if a property doesn't exist on a store, we listen just in case. If you listen to it, we create a signal. Now, if that signal is over top of a store and that underlying store updates, there's no linkage. It's not going to know to update the signal that you're reading from on top. So like in the case where you haven't actually overridden the value, but you've listened to it and then you change it, you kind of blocked it. So I was trying to like turn them into writable stores. Like I was like, okay, what if we have a signal with a previous value? And then like, okay, can we do this? But the problem is writable stores override. The whole point of them is a reset. Like whenever the source updates, you wipe out the ephemeral state and you start over again. This is the opposite. You want overrides to actually hold. Like I think like if you override something in a projection, now you can ignore the baseline store. You don't want that to come in and wipe out what you have there, right? It's the reset happens when you diff or when you replace a value. It shouldn't be happening like I mean, this is arguable, but I'm pretty like you override something for a reason. So I was like, okay, maybe you need two signals and memos and all this stuff. The solution here ended up actually being checking if the source is a proxy, and if so, relying on it for the value rather than the signal, but still subscribing to both. And then when it's an override, use the projections signal value, and when it's not an override, use the underlying stores value, but still subscribe to both. And you might be going, why use signals when you can just like read out the value here, just trigger the signal and then read the value? Well, concurrency. I want these projections to be safe for concurrent rendering, and which means any value that you read has to be in a signal, because only like random values are not like going to be concurrent aware, where like a signal would know whether its value or it drive signal or whatever is part of that transaction and is able to give the previous value or the current value or the future projected value based on that automatically. It's built into the model. So we actually want to read. We can't just like use signals as an event emitter, essentially like just like trigger the event, read from some value. We actually need the signals to own the data that they put out there. Otherwise, we can have tearing in our concurrency model, right? Some people wonder, but yes, Solid and Solid 2.0 will have it as well. We already have in 1.0 has concurrent rendering, like React does. Not just suspense, but actually multiple realities existing at the same time by forking the reactive graph. So this is a hard requirement here, which makes our, you start seeing why this is challenging. Source guarding, reconcilable. Yeah, there's a hidden other one here, concurrent safe. All right. Everyone's still alive? I'm sorry. This has been a lot of talking. This was a theoretical part of the stream. What about vectorization for diffing? Are you doing that under the wood? I'm not actually quite sure what you're referring to. The way the diff algorithm works here is we keep references. So we do like the typical, like if nothing's changed, basically we swap. What we do is we swap the value object underneath the proxy. Proxy stays stable. We switch the value object, and then we diff the signal properties, which are only things that are being listened to, and then we continue to walk down that. Because if there's no signal value being listened to, by swapping the source object, then you've already replaced everything under it, and it's safe to replace it with the new references all the way down the tree. But if something's listening to it, it might have signals and signals and signals down. So you walk down the things to listen to path, and then you swap then you go, okay, well, now we have a new value here. You swap that in that signal and diff and continue on there. But basically, we only diff with the 2.0 algorithm. We only diff the things being listened to. Otherwise, it's just a value swap that goes kind of unnoticed. Yeah, but yeah, so these are the qualities: stable references, source guarding, reconcilable, concurrent safe. But automatic diffing, no, and which means we don't have to worry about path-based or stuff. We can just assume things are generally by reference modeled, like I showed earlier, where they're the same objects. So back to stores. Protection uses the same mechanism of protection for app over stores. Since the condition is detectable, that may be the only situation we need more complicated reactivity logic. That's true, reactive pass-through. So this means the store mechanism did not need to worry about that and use signals initialize on read. We suggest a solution similar to what we have today, except the overrides when not listened, except we have overrides when not listened to. Probably a good place to start. Blah blah blah. Okay, so this brings me all the way back to the example that I posted on Twitter. I mean, we're only what, 3.5 hours in to get here? Maybe I should have started here because this is the exciting part. But this is to reward you, everyone who stayed to listen here. So let's look at the setup. Okay. I created 2 signals. I created a ref so we can check it later, and I created a store from that ref. I also created a projection that derives from that store. And I created some overridden properties that aren't on the store, A, B, C, and D. And there's a few different qualities here that I'm testing. I have A, I have B, I have A plus B, and then I have this one that actually self-references. The reason I wanted to show this off, just to point this out here, is like inside signals setters in Solid, if you've ever used like our like sets, like our set, let's say it's set count. There's a version where you can get the current count and then go like return count plus 1. There's like a function setter version. And while this is just, convenient for iterative stuff, it has another impact. It means that self-referencing doesn't track. Like if I don't do this, but if I did create effect, see, the problem is, I mean, who's done something maybe dumb like this in React, where they go set count and let's put like count plus 1, and they go, okay, no problem, it's not updating. Let's add count as a dependency. Sweet. And then they hit an infinite loop, right? The funny thing is, in a reactive system, this would also hit an infinite loop, right? Because you're setting the count of the thing. Like, again, don't do this, but it's kind of obvious. You're listening to count and you're setting count. This is an infinite loop. Now, you could solve this by using like untrack, right? Yay. But this is probably the most convenient place, because most of the time when you want the previous value, and it's not just silly counters like this, it's like if you're adding logs or doing something like this, this is automatically going to be untracked, essentially. So this is the same code, and there's no fear of it triggering something. Again, you shouldn't be in this situation anyways, because you shouldn't be writing state in effects like 99% of the time. There is a couple cases where you're like getting stuff from the UI. You're reading the UI and you want to write to signal. And then you definitely shouldn't be doing this during the pure part, like in memos or anything else. So like this almost never actually happens. But the funny thing is, with projections, I mean, doesn't it look like it's happening here, right? Like you're tracking, and then I'm listening to A and I'm writing A. Uh-oh. So as you can see, there is no infinite loop. So we don't self-track. But I mean, we have some interesting scenarios to look at here and try and understand what's going on. So let's run through them and see what if this makes sense to you. So first of all, I created an effect for every single, and this is using the split effect API that I'm sure you guys all love, but for every single property on the projection, including the ones coming from the base store. So I have A, B, C, D, X, Y, and even something that doesn't exist, Z. Okay. So unsurprisingly, we see our projection running once, which is that console log projecting. I keep count of how many times the projection runs. And then you see our effects log all the values of those things. Okay. People still with me? Still awake? No? Everyone's sleeping. All right. I'm going to share this in chat too. Thank you, Joseph. It helps to have someone alive in the chat. Yeah, I know. This is the cool part, though. This is the part. If the last half an hour to 40 minutes I've been just yakking theoretical stuff, this is the part you want to see. Yeah. Okay. Good. Well, Jack, you're still here. That's amazing. Okay. Cool. Okay. Okay. So let's talk about how this thing should work. First, if we update signal A, which is this thing here, what do we expect to run? Now, if this is a memo, it would trigger all the effects again, right? But if we update signal A, it runs the projection, and then what we see is it runs effect for A, C, and D. Let's check ourselves. A, C, and D. Now, don't get me wrong, it does actually try, in this example, run all the code and assign it, but because B doesn't change, because it doesn't need to run the effect for B, and obviously doesn't care, these haven't been touched either. So essentially, it does rerun all the code here, but because it ends up with only these three properties changing, and we subscribe to those three properties, then only those three effects run. Cool? Okay, let's keep on going. I mean, I think it's pretty easy to guess what happens next. If we update B, it runs the projection again, and then it only runs the two effects, right? And what are those two effects again? The one for B and the one for D, or sorry, the one for C, which is both. Now, let's start getting into some fun. What if we update store X? Let's look here. Store X is not used anywhere here. What do we expect to happen? Well, so I'm updating store X. I'm incrementing it by 1. Well, what ends up happening when we update store X is, let me scroll a little slower. It just updates projection X. It doesn't update, it just runs the effect. It doesn't run the projection. It doesn't need to. It just runs the one effect. Yeah, exactly. The projection won't run. Technically, it's a pass-through because we didn't override it, right? But how about update store Y? This is an interesting one. It's self-reading Y. So what should happen here? This one took me the longest to figure out. I'm not gonna lie. What should happen when we update Y? Well, you kind of everything to explode. If you think about it, you kind of want it to update. And it actually does update. It runs the projection and it updates both the effect for Y, which is the pass-through, and it updates D. And you're like, wait, why? Well, we haven't overridden Y, which means that listening to this potentially listens to both the projection, which we're nulling out, and the underlying store. So technically speaking, because this isn't overridden, this actually is actually tracking the underlying store. I'm pretty sure this is the correct behavior, but it's something to consider. Like if something's overridden, we're not going to listen to this story. Yeah, I know. I understand why this is like a lot, because you're like, what am I even doing? I haven't showed you real world examples. Not in this stream. In previous streams, I showed using this to do optimistic updates in Strello. I've shown this to do create selector, like on his selected projection. I showed this to do basically mimic map array, like anything that would require forking, because the problem is most reactivity, it emerges. You might start with 10 signals, but then you compute something that takes 3, and now you're converging. And that is used with another signal converging. And eventually you get to one big blob, and then React diffs it for you. What if you didn't have to go that way? What if you could keep the granularity throughout the graph while writing stuff in a very like granular kind of updating kind of way? Now, don't get me wrong, a lot of stuff should be memos. I said filters, things where you're like shrinking down a list or like doing that. But so projections are the least used. I expect this to be the 2 to 3% case. Like, but it needs to exist, because what it enables is very powerful things to be done performantly, which were not performantly before. I mean, this is the updated version of the primitive that I'd use in the Trello demo, because the key here is that we don't want to write to the create async, but we want to keep it diffable. We want to keep all those other properties. But so if you're not overriding it within the projection, it does make sense to not track it if it's used. Exactly. Yeah. So yeah, that's good. So we ran the projection again on that. Let's keep on going. Update store Z. I mean, this one should be pretty easy. Store Z doesn't exist, but we listened to it through the projection when we created this effect. So the projection is listening. So obviously it should obviously, sorry, where is it? See. It should obviously just not rerun the projection, but just update the value straight through. Okay. So it doesn't run projecting, but it just the values. I think this example doesn't really sit in until you actually view what the final store ends up with. Like you actually have a original reference that is the original object. You have a store that looks like this, and you have a projection that looks like something actually different. Do you know what I mean? Like in the end, you end up with 3 separate things. Like this is derived, but it updates, if you look at all these effects, completely granularly. Like there's nothing like this, or even really possible, I think, in the React ecosystem. Oh yeah. Oh, I mean, how do you know when the memo? I mean, yeah, I don't know. I think most of the, I think most of the time you can just use a function. I mean, the thing is, React still doesn't know when the memo. The compiler is making assumptions based on types, but it can't make assumptions based off, like that's the best it can do. It can't. It looks at like the type of objects and going, okay, that's a primitive value. You don't need to memorize it or whatever. But like you still might need the memo even with the React compiler. So like they haven't solved this problem for you. The final restore and projection are referentially distinct. Yes. These are not the same object. Yes. And I mean, I've been doing like let's play with this a bit more. Like, what if we delete p.x? What do you think happens? Like we've been adding an override. Like we haven't done an override here actually. Like, okay, let's before we delete p.x, let's make p.x equal some constant 5. Okay. Now, when everything's the same, but when we update store x, we no longer do any work, right? Because it's overridden. So updating the store doesn't cause the projection to run, doesn't cause the effect to run, because updating the underlying store doesn't matter because you've already overridden the value. I have a different example where I override it and then set it back again, and the store starts updating again. I'll show that in a minute, but like generally speaking, if it's overridden, then we don't care anymore, right? You've made the decision to override it. Okay. And if you look here, it's 1, 2, 5, like different values. But it's the same thing with delete. Delete p dot x. You can protect properties. You can go like, look, ref has x and y, file store has x and y, projection does not have x. So, and again, when we update the store for x, it doesn't propagate and run any effects because the projection doesn't have x, doesn't care, right? Like it's just undefined. Like this is completely granular. You can literally change the shapes of your objects and have it not impact the underlying store, yet be able to trigger exactly what effects matter, like or side effects or track or whatever, right? Type deaths or this. I mean, the funniest thing is, yeah, I mean, this is kind of interesting. Most people's stores and projections actually follow a fixed state. So you're not actually like our fixed shape. So you like your type is going to be your schema. And then what you get back from the store, the types aren't in here. It's weird. I, I mean, I don't even know why the TypeScript isn't working because I have the TS in here, don't I? Oh, maybe not. Maybe yeah, this is a JS. That's why there's no TypeScript in here. What I'm getting is projections and stores generally can return basically read-only values, so you know not to write them. Like generally, people have more fixed schemas. This is like a little bit. We're going crazy here. Are projections going to become the new props and solid components? I know you talked about using streams eventually. No, because props aren't anything. Props are just function wrappers. We don't need something this complicated for props, right? Like in the same way that if for something shallow, Joe didn't need anything complicated. He just made a few getters for his to-dos. We don't need to be deep here. We don't need the diff here. Props, they're shallow getters essentially. So where you want this is in cases where you are specifically talking about deep derived data stores. I said, I was talking to Dev about this a bunch, and the funniest thing is we think projections are actually going to get used a ton with async data. We already know they're going to, because you're going to sorry, go back to one of these other examples, but we know that you're going to like do, actually, was it actually in this example? Maybe not. I already closed it. We know you're going to go like, now whatever. You create async, and then you're going to like diff stuff or like do a projection optimistic updates. Like that's going to be a place where you might use it. Like if you want to create async store, it's basically a projection over create async. Like that's a place, right? You just reconcile, you just diff it. That's a place where you're going to use projections. But this whole store over projection case is actually fairly rare. Like most of the time, you're going to have data events coming from outside the system that are going to talk in diffs. Or they're going to diff on entry, like the reconcile that I just talked about, right? Like if you have a sync engine, these are events, they're discrete events, and you're going to combine it. Then once you're in the system, most of the time you are filtering down a bit. You have a list of to-dos, you're only showing the 3 that are active. You know what I mean? So like there is still mostly create memo once you get in. My gut feeling here is that projections over stores, while capable here, which is super powerful, I don't know how many actual use cases. This is only the case where you actually have to project diffs throughout the whole system. And my opinion is diffs are better as events than as state, which means that this kind of belongs before it ever enters solid. So maybe I've created something very niche, but I think the more important part here is understanding how the first principles apply, that this is what a store is. This is what a projection is. These characteristics are how these things should behave. I don't know what anyone's going to do with them yet. To be fair, except for the 5 or 6 use cases, which are all very important use cases. But actually, the store, like we started the store here, but technically the store could be injected inside the projection itself. It doesn't need to be the starting point. You could like put a store on a certain thing. You could like use a projection to wrap a store, put multiple stores together, or you know what I mean? Um, yeah, it's beautiful to project and fork and keep granularity. It is. Yeah, writable projections as well, right? By keeping the API the same. I mean, I haven't played with this. I mean, I've implemented it in this example, but I haven't actually like done examples with it. But yes, you can create writable projections, right? If you go create store and pass it a function, then you can both project it automatically or write it. Now, that's an interesting thing. Should the semantics change at all? Because basically, its last update wins, which is the same as linked signals if you think about it, right? If the source updates, it overrides. If you write to it, it overrides, and then back and forth. Mechanically, we know it's a swap. But the key part is that projections have that protection, that firewall built in. Now, I'd like to give that firewall to other primitives, but you understand that where the real power here is when you, instead of viewing this by its discrete parts, you view stores and projections as a new type of thing. They are mutable reactivity and derive mutable reactivity. They are different than their predecessors. The combination of their parts actually makes them into a very, very special kind of primitive. Now, I don't know if create projection is the right name. It's a freaking pain in the ass to type. It's like too long, but I I don't know. Like I think this is something special and something powerful, and it it, it fits into a class of problems which there are real examples of, and are large also ones that are largely theoretical. So I'm like very excited to see how this actually pans out. This is not something where I can point at the specific use case outside of the Strello demo, like the optimistic updates, um, where it works so well. But you, I mean, creates like, I mean, I have a bunch of those use cases, but I feel like um, it takes a bit. But does it take any more than going to that Signia example and writing your stuff on all diffs? I think it's infinitely easier to write stuff in terms of a immutable API than it is to um, basically work in a world of taking previous patches and generating new patches from those patches. Yes, this is the equivalent of the fine grained create memo. Yes, that's the idea. Yeah, the main use case will be client state diverging from server state and then periodically syncing back to server. Yes, exactly. And what's cool is because it's reconcilable, if if you're on the happy path, that syncing might actually mostly be very little work. Do these nest like merge, or is it combining with store? Yeah, okay. Yeah, so stores are the same object. So when you take something from store one and put in store B, you end up with the same object. The model reference, the model is kept the same. Projections are key to the projection that created them because they also need a special. There's the way the firewall works is there's a hidden signal that does some funny business. So if you take a projection and you put something in another projection, you are going to be wrapping it again. It's per projection that it wraps. So yes, you could, if you're projecting into projecting and projecting, you could be wrapping proxy on proxy and proxy and proxy, but each of those proxies would have the behavior that I just displayed today. So it might eventually slow things down, but it would be correct and granular. Yeah. Yeah. Store as I said, stores are like signals or identity. You know, when you move pass a signal around, it's the same signal, right? Whereas projections are like memos. When you wrap, a projection, yeah, you wrap it and wrap it, or like props, right? Every prop you send down the tree gets wrapped in another getter. Usually props don't drill that thing, but there's like a very small overhead when you have a. I often say, oh, you know, overhead on components, but like if you pass a prop from the top down through 10 components, technically speaking, there is going to be 10 function wrappers around each of those, like getters. There's going to so when it executes, it's going to call a function, 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 return the value. Does a function wrapper cost very much? As it turns out, not really at all. But I think my expectation is most props generally only go about 3 to 5 components deep max. Like people don't want to deal with prop drilling beyond about 3 to 5 components. So then they switch to context and it's fine. So like it's not a big deal. So what happens if you create a projection within a projection and then use that nested projection within it? Yeah, okay. Let me think about that. Yeah, okay. I think you actually, it's possible that you could create an infinite loop the same way you could if you reverted memos. One of the nice things about memos is it's hard to reference them like before they're created. Like it's a pain in the ass to do a memo in a memo. Like reverse it, like make a memo rely on a memo that relies on a memo, because you basically have to declare all your variables up top and then put them in the scopes and then read one and then pull through and then have it loop. Now, to be fair, in Solid 1.0, it's impossible to do it because they run immediately. So they'll just hit the reference, hit null, and just crash out. Solid 2.0 and all push-pull based systems, actually, it's possible to create memo infinite loops. So this is a new type of problem that I haven't hit in the last several years of Solid. The way you write stuff will get away from it. This is an argument for why I say writable projections maybe are a bad idea, like because the way stuff lays is more likely to, like when it's like inside a memo or whatever. Like what I mean by that is like if you have like const, like how do you make A depend on B and B depend on A, right? Making B depend on A is pretty simple, but like I mean, this is going to fail in Solid 1.0, but my point is you cannot access before initialization, right? So the answer is let B, or sorry, B equals this, and then let B, but then you're going to get B is not a function because it runs eagerly. But like what I'm getting at is because of the, like, it's actually unlikely that people are going to create these kind of loops. But if a projection is writable and then it can take a store from above and write it into it, it's more, or store from below and write that into it, then it's more likely to happen. So yeah, this is an interesting consideration. I mean, I don't know. It's hard, right? Because if you merge them, then the independent things should no longer exist anymore. Because otherwise, you're just creating a new thing, right? Like, it's not like props or destructuring where it's a scenario where people are just doing it down the tree and you're basically forcing people into like building these proxies. It's like I think people will create projections intently, like not be like, okay, I'm gonna make a projection and then I'm gonna just throw this into projection, throw this into projection. I don't see that happening in the same sort of way. Like you could only successfully merge something like this if you knew for sure that no one was gonna read the intermediate. But in that case, then like why are you doing it? You know what I mean? I'm not sure. It's any sort of merge would like it's just a funny thing because like even the merge operator in solid for like proxies and stores and props and stuff doesn't actually merge the object. It just actually makes another wrapper, around both of them and put them together. So it's like I don't know if merging is a real thing. Yeah, I did cover the firewall logic on stream a while ago. Like to be fair, Milo has a better solution in his new R3. The trick that I did, which is kind of silly if you think about it, is I made it that the projection still has a signal that everyone who listens to the projection listens to, right? So like if I go in here and let's look at the proxy for. This is my favorite thing about the create projection thing right now is sorry, I'm in the wrong playground. I'm missing an E. Yeah. If you look at the implementation here, it's kind of funny because like there's a projection computed, which is a special kind of lazy computed that wraps the store setter function essentially. But what I'm getting at is the trap for a projection is almost identical to the traps for a normal store, except what it does is it gets the observer, and this is how we do the ignore part of it. Basically, if there's no observer or the observer isn't yourself, then read from that observer. But the trick, what it does is every single node still ends up that listens to projection. If the 1,000 different places does end up subscribing to this projection node, but the special projection computation, it does some kind of weird notification thing where it doesn't queue effects. And because this is a push-pull system, you need to queue effects for any work to actually get done. So what it does is it notifies the whole graph, basically like, hey, look, you may have updated, but it doesn't actually cause any of the work to happen. And then one of two things happen. Something reads from the projection somewhere, one of its things. It goes, oh, I could be dirty. And when it goes, I could be dirty, it actually pulls through and that makes the projection run at that point. And the funny thing is, the thing that pulls through sees the updated value, but the projection computation itself returns undefined, which means its value never changes. So even though it tells everyone I may have changed, it's a false warning. It never changes, but it also never schedules the expensive work. So it means that you kind of you let the system act lazily still, where it doesn't do the work until it's asked, but you're also telling everyone that, hey, you could be dirty. And then when the projection actually runs, it has all the discrete signals inside, which at that point, those signals will notify the things that have actually changed with the new value and update them. So basically, at that point, it kind of re-notifies. There's like basically two types of notification, and overrides the other notification, and then only has those ones cue their effects to run, which then pulls the right values down and skips the rest of the graph that isn't impacted. I don't know if that makes sense. It's kind of complicated, but it means that it does this interesting thing where it kind of, see if not this force notify return, it basically halts the propagation of the effect notification, and then waits. This is the thing is, this can't exist outside of a root because it is actually scheduled. If you don't pull from it, when the flush happens at the next micro task, it will do it. And we run all the projections first. So before you run other memos or whatever, the projections get scheduled first. Now, if they depend on another projection, you're still fine because you've notified them that they're actually, I don't even know if they need to run first because you've notified everyone. Actually, sorry, yeah, I think the projections just run in the pure queue. Because you've notified everyone, if anyone reads it first during that queue run, or if a projection reads another projection, well, that other projection will then run first before that projection and then cause it to, like, basically there's no way to get an out of date value, and it's still on demand. So it's a very, I don't want to call it hacky, but a very mechanical solution that, again, I was skeptical of, but I actually benchmarked it, and it is slower than like our specialized selector primitive, for example, we have installed today, but it's actually faster than doing the naive thing, and even, so it's actually even faster than putting the signals on every single. I guess it's about the same as putting the signals on everything. In either case, like, it basically gives us the behavior we want, um, in a way that is consistently safe, but it does so by potentially over notifying. The ironic thing is, when I was working with Milo on R3, his new push-based system, this behavior is exactly the same as what the fallback behavior he does when he can't depend on height-based. So, like, basically his worst case scenario is still this scenario, which isn't even that bad. So it's like, it's kind of cool. I don't know if that makes sense. Yes, exactly. That's the thing. I said a bit earlier. Stores with projections might not be a common case. To be fair, I think a lot of this kind of stuff happens outside of the system. Yeah. You can make a circular dependency, but I'm just saying that people generally, because they write code top to bottom, they don't end up wiring it that way, because you have to declare the variables above and then use them before. Like, it's not the way you naturally write the code. Oh, okay. Good to know. I think people, yeah, okay. Dev's back. You missed the whole stream. Yeah. We're on firewalls already. No, I just showed off the projection primitive, which is pretty cool. And yeah, I was talking about firewalls. Yeah. No, these projections are lazy. Yeah, I don't know. I guess you were probably here for that explanation. I wonder if you could have a cheap deep clone memory pointer that would solve some of the issues caused you just compare memory pointer. I feel having this in the browser is really an issue. Sometimes the deep cloning and strict cloning just not it. Yeah. But yeah, so my solution to, like most things, use a proxy. Yeah. I mean, to be fair, you can kind of understand. I showed Tanner this demo, and he was like, "What are you showing me?" I get it. This isn't the thing is, this is just such a powerful thing that it's almost unprecedented. But actually, Tanner sent me a message so he watched part of the stream. So yeah. Or no, I think he's actually I think actually he didn't watch the stream. I think he read my explanation and then sent me a message while I was streaming. That's funny. Let me see here. This is like a completely different idea. So maybe this is not something that's easy to show. Let me see if I can find my original demo. No, not this one. Sorry, give me a second. I got one more projection demo I want to show if I can find it. Damn it. Give me 2 seconds. Just checking it off screen. Sorry. Not that one. Not that one. Not the deep. I got deep performance working well too, so that's not a problem. Okay, this one. Um, let's grab this. Sorry, I have all these demos that are in different forms of this. Okay, so let's do a quick look at this one. Um, this one's a kind of funny one. Uh, it, I start with a store that has foo and bar, and then bar becomes foo, and then bar become new bar. So it's like a shifting to the past thing, and then it's based on the store, and then I have an effect that runs. Okay, so that checks whenever foo changes. So most of the time it runs. Okay, so let's turn off warnings. Okay, there we go. If you've been seeing these warnings, it's because projections do have to run under roots because of the way they're scheduled. Unfortunately, I haven't figured out a way to get around that. It would be nice if they didn't, but it's tricky. It maybe, I guess, the same rules that would let you release a memo could let you release a projection. I think they'll be interesting when we get to that point. I still haven't got that working. I know a lot of systems have that capability. I just haven't figured that out in a performant way. Anyway, running projection one time, projection foo equals bar. So initially we've swapped it. So foo equals bar and bar equals foo, because what we do here is we bar starts as foo. Okay, I know, lovely, confusing. Okay, and then what do we do? Nothing fancy. Then we update the signal to trigger the projection. So what do we do here? We set bar to Baz, and unsurprisingly, it runs our effect. This says foo is now back to foo because it got it from bar, which was previously foo, and projection foo equals foo, and bar equals Baz. Lovely. And now we have our second snapshot of the store in the projection, right? So initially we swap them. Now the foos are the same, and the Baz overrides the bar. So now let's update the store with a new property. Let's add store Baz, which is good. You notice the projection doesn't rerun, and Baz is true. Okay, so this is not right, not a big deal because the projection doesn't run. And then change on over baseless store. Then what I do is I actually update foo to foo2. Even though we previously updated it, foo went back to being the original value here. So at the point that we update, so we like reset it basically. At the point that we now update it to foo2, we see the new value, and it updates and runs the effect still because it changes it, and it goes in both places. So like the override actually goes away essentially, and it goes back to working. That's the only point I wanted to show with this demo, that like you can reset the override by setting things back to what the underlying store is. It's not the most intuitive way, but it's hard. It makes sense when you think about diffing and reconciling, because the problem is deleting has different semantics. We already talked about it. Like if you want to be able to delete something in the projection that's on the store, you actually have to say that, hey, this is deleted. You can't just say, you can't use delete to say now I want to pass through and get rid of the override, because you need a way to say like the way that I came up with is actually just reset the value back to the base store value. Again, I don't know if it makes a ton of sense. And if you did a diff, that is what would happen. So I think this follows anyways. Yeah, I think it'll take a while too. You can sync internal component state with receive props much more easily, kind of like an optimistic update. Assuming the prop value is something async, I'd have to play around. That's fully recommended. Well, that's the other crazy thing, right? I'm making these models that are like these primitives here that are concurrent safe, and then this also feeds into the whole async thing that we've been working on, right? Like all these pieces have to work together in a way that's makes sense. So yeah, I mean, a projection is basically a spreadsheet. Yeah, in case we want a spreadsheet with dynamic columns, so let's calculate drive values. I mean, I can think of ways to do this, but yeah, I mean, the biggest benefit of projections, I think, is like the optimistic updates. It's the ephemeral state. It's like being able to take something and then enhance it with granular mutations and granular things and like build out something on top. And then, yeah, I mean, you might keep it like that, if it's client only, but you might save that to the server. And then when it comes back around again, be like, okay, now I just want to reset it to what this is. And the key part is if you use reconcile in that reset case, you keep stable references. You don't have to re-render anything. You don't have to rerun any components, right? Like the reset hopefully will just be the thing. Yeah, the way I built projections should work with transitions. That was one of my requirements here. Concurrent safe. Concurrent safe is an interesting one because people don't really think about it. It's hard to understand the rules in perhaps in React, but the the way things become unsafe for concurrency is when you have something out here, like let x equals 5, and then you have like I'm trying to think of an example of this, but if something like people shouldn't be doing side effects and create memo, but if something reads from this X kind of incidentally, um, and this X can change, you know, for some reason, again, why is this not reactive? I don't know, but it's, well, like let's say you use this to cache the previous value, right? This is a logistic thing so that you can diff. So then you're like diff value previous value. This is probably the most common case. You're doing something like a shallow diff. I'm just calling it diff function, but it doesn't matter what it is. Okay, so we're doing something like this. Now, this isn't concurrent safe. I'm going to give it an object more thing. This isn't concurrent safe because the problem is, depending when this runs, this previous value is getting set from somewhere, right? Because you might do something like this, right? So, like, depending on your path, you might end up with different previous's, which give you different diffs, which give you in a world of trouble, right? Because it's not the state you're working off of. However, in Solid, our memos have previous built in. And now we control what previous value. We can tell if you're in a transition or not. We can give you the appropriate previous value. So like the diff problem kind of goes away because we control the inputs. We fork the graph, fork the previous value as it was versus what it will be and what it could be, and like different realities. They can not only the value, but the previous value can also live in different timelines. And these are all connected, and the graph's all connected. So basically, as long as we don't have these dangling references, it's going to be concurrent safe. So I just have to design my primitives that way. And it's part of the reason why we have stuff like previous value here. I know a lot of frameworks or signals libraries don't do this. Again, this is about it's kind of ironic, right? Like you can compile away this. Like, what if our memos were just this? Guess what? You don't have to type a function. Good for you. There's something that's congruent that lends to the shape of the system, right? The same way that stores are projections and or like linked signals and memos, like that kind of symmetry that comes in the shape of the solution. And I think that because of little things like this being built into the API, it discourages people, like it gives people the right path to follow to begin with. Like this is why it takes so long to build these primitives. You have to kind of look out into the space of all potential solutions and then try and think about how people would potentially use them and what the benefits or whatnot. And previous would just happen to be like something I maybe picked up from SJS, and I thought it was kind of like a good idea, and it makes sense, and it like let you do reducing operations, which is powerful, and let you like in a non-track way, and like it makes a lot of sense. But it then like you have this happy coincidence or thing when you realize that it's actually the thing that's going to save concurrent rendering on a granular scale, because every node has its own both internal state and previous state. Anyway, does that make any sense? I'm sorry, I get deep. It's not spelt. Oh yeah. I mean, I don't even want to think about the no. To be fair, Svelte new Svelte doesn't have the problem. You'd have to say like dollar sign whatever. Old Svelte, yeah, I don't even know. I mean, this is one of the challenges I mean had working on Marco too, because you have like there's reason. I mean, you could be explicit in like force on tracks and stuff, which is arguably a good thing, but there's a difference between initializing a signal with a value and a link signal. And again, this is one that's very easy to remove the syntax for. Now, don't get me wrong. You can always have, you can always make like a subclass and be like, look, I have signal.linked, or I have, computed dot I don't know, or was it is it derived dot by this, and add this thing. So like it's not like you're losing anything. You can always add more and more APIs to do all the different use cases. It's just really kind of cool when you can look at the whole spectrum and go, look, I got 1, 2, 3, 4, 5 primitives, and they like just five primitives, not like those primitives and dot by and dot linked and whatever. And those 5 primitives literally handle everything. I mean, don't get me wrong, there's a few helper functions and like, like map array and untrack and, those kind of things, snapshot we saw today, deep. But like generally from like, what are your signals? It's just like, here they are. You can fit it on one page. I think that's always been what's attractive to me about these solutions. You're like signal, memo, effect. All right. This is the main content. Let's do a little quick this week in JavaScript and go on. I hope somebody got some value from this. I'm trying to get value to figure out how to explain this stuff. And the truth of the matter is today probably wasn't the explanation stream so much. It's like, look at the cool things I can do stream. And I'm going to have to work on the messaging here quite a bit, I think. It's, as I said, unprecedented. It's another one of those big things, but this is one of those ones that people might just like not get, might be like, who cares? We'll add it. I remember Evan a little while back when he's talking about the JS framework benchmark, and he to be fair, he said kinda, but he's like, Solid's kind of cheating here, and I'm like, that's one person's perspective, in the benchmark. The other perspective is we're just opening the door to a whole other world of how we can model solutions for problems. And I think that's incredible. Yeah, the prev inside the function keeps the pure function. Otherwise, there's a really good API design. Yeah. Yeah, and we had that. We had the Strello demo. The Strello demo is amazing. But yeah. I mean, it's always been the DevRel and the Solid 1.0 was hard. Like if we were actually good at DevRel, or like I could somehow Pete Hunt the world, so to speak. Like in some ways, Pete Hunt's my hero. He had no problem going out and just like straight up, just like being opinionated. Then I think we might be in a different place. I mean, Rich Harris even a bit of that, right? He was so definitive. I'm always like, I'm like when you put the guy who says it depends on stage. It's like, if someone asks a question, I'm like, it depends. The reality is a lot of it depends. But that just because I say it depends and I tend to apologize for whenever I give forceful opinions. It doesn't mean that I don't think I'm correct or that these things are better or even significantly better. That's just like maybe being Canadian. I mean, oh yeah, yeah. You actually, we actually, yes. Query params, I had to make a special type of object to do it in the router. It was called a memo object, and in hindsight, a memo object is actually a projection. Yes, this is another use case because it it derives from a store, or sorry, a source like the URL, which is basically a signal, but you want to then split it out, um, and you want it to be dynamic. Yes, yes. If you want to get super deep, see, I don't know if it's worth it. I had to make a version of the router that doesn't work with proxies. There's people, a lot of people, big use of Solid is in non-proxy environments. We're still very, very popular in television apps of big companies like Universal, NBC, that kind of thing. And so I have to make common libraries not depend on proxies. But I got to a point where we just have a switch. Like we work with proxies, and then we give them a way to inject a non-proxy version. But yeah, it's something, projections are like, and stores are just all in proxy. I think I'm hoping that those systems get proxies eventually, or like slowly phase out. Like they have, almost all the systems have proxies today, but like we didn't get proxies in Chrome till like, I don't know, like 47, and they're basically impossible to polyfill. But yeah, no, good example. Yeah, I mean, use them in your vanilla thing. Like Solid is just in a sense, this stuff plus like a JSX compiler over vanilla, right? You can just skip the JSX compiler, like maybe the last bastion of just JavaScript, because we can actually do that. Like React kind of claimed that, but like they never were quite that. Like 90% of what makes Solid great has nothing to do with components or JSX. Yeah, it's definitely a Canadian thing. Forms as well. Yeah. Okay. Yeah, I just got to be careful of not being too forceful. And I mean, it's interesting. Sometimes, like classically, when I built Solid, I would avoid stores or projections everywhere possible to keep the bundle sizes smaller. Um, Signals without stores or projections, like you can make like a basic example, it's like 2 or 3 kilobytes. So like it's basically nothing. Like even with the JSX and Solid and all that, like you like I guess like what's Hello World in Solid in Vite? Something like I did do MVC a little while back, and it was like around just over 4 kilobytes or something. But like use rollup, it's slightly smaller, But my point is like I would avoid it because I didn't want the base of the library to be like, oh, it's actually like 6 kilobytes. It's people sensitive to that. I I've changed a bit here. The store, like you can still choose not to use it, but like solid signals ships with the store and projection things. I think it's the base primitive. And there's a bunch of other stuff. Luckily, we're really good at tree shaking, so I'm okay with it. And I think stuff might get a little bit bigger. Reactively is a little like less size optimized, but I mean, I think Svelte's actually bigger than SolidJS now, so like we have some room. Before that was the thing, we were like up against Svelte, and in their small components, like obviously we scaled way better than them, but they could still like we need to be in spitting distance. Preact's another one. So I do kind of keep track of size, but I think I'm okay being like maybe like you know a kilobyte or half a kilobyte bigger than those solutions, given like what we do is just so much more in a certain way. Like, I mean, Svelte's different now. Svelte is more now, so they actually are larger. So like they're a better guideline for where I want to sit. But like I think Preact's going to stay minimal. So yeah, I mean, Yeah, state management. Yeah, that's cool. And the signals library, this library that I'm showing here, this reactivity.ts, is a separate library you can use separate of all the other stuff. I think it will be very convenient for you in the future. It's probably two versions of most libraries, the small one and the fast one. Yeah, no, there's a three versions, and then there's the popular one that's neither small nor fast. Well, because the popular one actually has to deal with all the freaking edge cases. To be both small and fast, you generally have to concede to a certain thing. And over time, libraries get bigger, not because they're trying to get slower or larger. It's just because they want to appeal to a wider group of people where like certain behavior no longer is acceptable. It was okay with the niche users. Now they're not. So, you know, for React classically, it was Preact small, Inferno fast, React neither, right? Solid has that kind of thing happening in its future. We are smaller and we're faster, but reality is at some point there's probably going to be I mean, there's already smaller ones. And there's probably going to be like we're probably going to make a decision at some point that takes the last like 0.1% of performance or whatever and sacrifices it for usability. I mean, we might have already made that decision and now we're stuck with it. But like as we get more popular, like I think we're always going to like there's always going to be that risk of being on the React trajectory. And I mean, not obviously it's the next generation, so it's going to be better than React is, but comparatively, things keep on moving. It's reality. Just rendered the hold the hum through create projection. There we go. Oh man. Anyways, sorry. Let's get this set up. Give me 2 seconds. I mean, I should have been doing that while I was talking. I wasn't thinking. I'm just closing some stuff down. All right. All right. Sorry, just switching gears always takes a minute. Let's get the bookmarks in a new tab, profile, and then solid.js. Okay. All right. I think I'm finally getting used to my new setup here and being in. It's funny when you move big place, it takes a while to get oriented. I think I'm finally feeling oriented here. Took like a month. So, yeah. Okay. So what are we doing? When was the last time we streamed? Only a week ago. So we don't actually have much here, which is good because I don't want to get stuck on this forever. Today is the 18th, so we're going back to the 11th. Beautiful. All right, let's do this. Let's talk about this week in JavaScript. It's funny, I still like the only banner I use, but let's do it. All right. So I mentioned a little bit earlier that I kind of got into silly Twitter stuff this week a lot, which is all silly, honestly. But I know this is just being sensational, and my response is just being sensational, but I want to start here. Svizek said here, React smoothly redrawing 20,000 DOM nodes, but yeah, I'm sure it's too slow for your CRUD UI. React is fast enough. The thing from this perspective, the problem is, how should I put it? The DOM is the overhead here. Almost all frameworks actually generate the same DOM updates. It's how they get to those DOM updates. So if your path from state to DOM is like a direct line, then React should be as fast as almost anything, right? Obviously, like maybe there's a bit of VDOM overhead, but like it's the distance you get from the DOM, the number of components, the layers, the abstractions, the diffing, the state, like that actually gets you farther away. So like in benchmarks, we always use a ton of DOM nodes, and then we focus in on the difference in like around those. Like 90% of the cost is in the baseline, like the vanilla JS implementation, and then we just zero in on that little overhead as an idea of getting it. But the problem is like you actually get a better idea of the overhead the more complicated the scenario you make. But the more complicated scenario you make, the less likely people will be able to implement in all the different tools, and that you'll actually have a comparable benchmark. So seeing something like this would never bug me. Honestly, I was like, whatever, guys, just talking stuff, right? This is too many DOM notes for the Chrome Dev Tools to do. There's no memos in here. I use React Query. Well, I mean, that is a sort of memo. Ryan Florence came in a bit later. But I started reading the links, and it's too bad MJ actually wasn't the first one I read originally. But it's like I started seeing stuff like this is why I'm skeptical of rendering libraries with micro benchmarks showing what they're like so much faster than React. React is already fast enough. This is probably more a testament. See, that's a good answer. But there was a few others. Problems with React, the DOM. But don't provide code to do a to-do list. It's funny that these got pushed down. A bunch of the original responses were like basically like Michael Jackson's, or like, yeah, rallying behind, it's this is my problem for retweeting it. Yeah, like this one. But signals are faster, like is this what? Anyways, I saw this and I was like, sorry, actually, maybe I want to go into see what people responded to the conversation with Michael Jackson for a second. Like, I keep on hearing this fast enough, but it's like, what does that even mean? Do you know what I mean? Like, at a certain point, I just hear like, I think part of the problem is it's almost convenient for the narrative around like signals frameworks to be let's make it about performance, and then let's say that the performance is good enough, and then we can just disregard the whole thing. Like that's the kind of line of thinking, and but it's gotten so much to a point that people can't ignore it anymore, to the point that like I was seeing articles and stuff, and it like in defense of React is basically like it's fast enough. And after a point, it was just like I was like it sounds so common that it's like fast enough TM, you know what I mean? And I started when I read Brian Florence, and obviously because Remix with 3 is coming out and stuff, and I was thinking in my head, I'm like let's think. I'm positioning my framework. Like, is it wrong to say that, hey, something's good for performance? Like it feels like it's almost like signals get insulted almost at this point for being performant, because it's like, oh yeah, it's because you care about this. It's like derivative. And I'm like, why? How can you rally around being fast enough? Like Michael Jackson's not going to go be like, guys, check it out. Remix 3, the fast enough framework. Like no one is going to do that. Like being more performant is a good thing. Now you can try and detract from other aspects for the trade-offs involved or whatever, but no one is like, yeah, it's just kind of something that I was just thinking about. Like nobody would market themselves as fast enough, yet that is one of the most common things that I hear. See, the statement implies a compromise, and there's always compromises, right? It depends. That's me speaking. But I don't think it's the compromise that some people think. Yeah, exactly. Like I don't think people do choose it, but it's way too easy to use performance to discard. The problem is, it's so ironic. I needed to focus on performance because React actually used performance as part of the way that it won. They actually said the VDOM is fast, sort of. Like, actually, that's not true. Jordan Walk said the VDOM is not that slow. But somehow, like, over time that message changed. Largely after Ryan Florence's talk in that benchmark, they actually used same guy remixed or whatever. Like they actually used that argument to get React in the door, and now they're like fast enough. To be fair, that's Ryan, not Michael. I shouldn't say they're the same person, but like it's funny a little bit. You know what I mean? Like, I obviously that wasn't the only thing they're arguing there, but like, no one ever really chose the thing on performance fast enough. People kind of know it's what I was trying to get at. Parts are rarely about raw performance until you hit a problem. It's about the model that gives you confidence to build without worrying about it. How much confident are you in fast enough here? So if someone's just like, yeah, don't worry, it's fast enough. Well, someone like we know in the universe of things, at least a certain number of people don't agree that it's fast enough. There's a certain number of cases. Otherwise, you're right, no one would care, right? So you're just betting on that it won't be you. I know this happens to other people, but not to me, right? I thought Aaron from Zero, actually made a pretty good point, because we actually use this exact same kind of thinking or language when we were promoting Marco internally in eBay. One way I put it with Zero is, why should Zero queries update in 0 milliseconds? Because users have 60 milliseconds to render a frame, and we should not be consuming any of that. It should go to the app. You could try framing solid that way. Your app's complex, your UI should be fast, so your app is much more CPU as possible. Exactly. I think that's clean. In solid, the architecture can lead to even lesser user code running, right? Because of the reactivity. But it's better to draw people to the why. The why is that your performance budget is something you spend. Why spend it here when you can spend it where it counts, right? That's the argument. Like, yeah. I will add that the initial render on this is absolutely brutal. Main thread glitches for several seconds while parsing the data. Even the loading spinner stops spinning. I'm sure it would for every framework. I don't think this is React specific. So this is like yeah. I had a much longer tweet written up talking about the challenges in characterizing performance, how it goes both ways, like meaningless, how fast we update text, say, in Solid.js. But I realized after seeing the responses that we might be seeing fast enough TM. Yeah, because the truth of the matter is I actually wrote a way longer tweet, and then I'm just like, no one's going to read this, where I was like talking about like there's observable speed versus non-observable speed. Like people pick up Solid and then they go update a text node as fast as possible, and they're like, yeah, Solid's fast. Like we are the fastest at updating a text node on a major libraries classically. But it's like, that's meaningless performance. But it's the easiest thing to confirm. So like this can work both ways, like this sort of situation. I think people need to understand the architectural pieces to actually understand the real benefit, right? Also, what condition is it fast enough? Xbox only switched to Edge from Internet Explorer. TVs run on CPUs of RAM, or oh yeah, God, yeah. This is what I was talking about before. TVs are brutal. So yeah, fast enough's a moving target. What you think is fast enough for you today may not be fast enough for you tomorrow. Even Blazor is fast enough. Yeah, this is probably my fault that the Blazors become the butt of jokes in the Solid community. Anyways, confident enough. Extremely confident. Yeah, this is the same guy. See, I could tell that it's sarcasm. Only the Sith deal in absolutes. No, and influencers on Twitter. That's something I got to get better at. Anyway, that was why I was calling this one out. See, I thought this was a cool tweet when I first read this, right? I've been saying this forever, right? I was like, don't add signals to React. It makes them slower. Even Blazor's sold on performance. Yeah, to be fair, it wasn't the original post that I was getting at so much as like the way people were responding to it, and the fact that I hear this a lot. When you need to optimize something, you should be able to go down a layer of abstraction. Right. Like adding signals, adding compiler, adding all this stuff. doesn't make things simpler. It might make things easier. See, so when you add a state library to React, it makes it easier for you to write more performant code. It doesn't make React faster. The compiler is an interesting one because it does sort of the same thing, but very effectively. It almost makes any code into the most optimal React code. But it doesn't make React faster, right? So in theory, if you are an expert, this is true. You should not be asked to go up by introducing a new layer on top. But not everyone is an expert. But I just want to, but I'm like, you know me, you know my audience, you know things. I like expert takes. This is great. Then I read the next tweet. The compiler can just signals will then, the hooks will automatically, the bundle will magically. And I'm like, I was like, okay, well, let's talk about this for a second. You can technically optimize by adding a compiler. You can technically optimize by adding signals. And you can definitely optimize by adding a bundler. All these things can actually make your code, like resumability is a compiler bundler trick that, to be fair, you could do it by hand, but good luck with that. Signals let you get rid of the VDOM. That's instantly a huge optimization win without doing other stuff. Of course, just adding a layer is pointless, but it's possible to shift the where's my response? It's possible that what you're stuck with is an architecture based on an API. Right. So like picture if you're using React and then you want to change the architecture to something like Solid, you could in theory migrate to legend state and then eventually just pull the rug under React. That could be a migration strategy, right? And in a sense, like Preact could be pulling some crazy migration strategy where they eventually drop the React model essentially and go straight fine grained like Solid because you move to these helpers and then eventually get rid of the virtual DOM. So like generally speaking, adding signals to React and Preact won't do anything, but adding signals to remove the VDOM, that's huge, right? Sometimes I did this in one of my early companies where we created a facade layer of the API and then gutted everything underneath and kept the same interface and drastically improved the performance of what we were doing. But it wasn't, we couldn't do it in one step, right? So I think this is like, there's exception. To be fair, I won't consider that moving up a layer anymore, but building a different foundation. But were it a migration strategy, that would be a reason to introduce something higher up short term. It's hard to move boundaries, right? Yeah, it's not practical, right? To avoid the VDOM. Sorry, 2 secs. All right. Anyway, I think part of this is that people don't understand what going down a layer. Like React set the baseline so high that people aren't as close to the vanilla anymore. But it was just interesting to me because I made a visual of this because I was trying to like think of how to explain this, because sometimes building the facade is the bridge to getting out of a local minimum, like getting stuck, right? And actually, Ryan looks like he agrees with me. He said something here. Rotate it on the third dimension and you see you're on the wrong mountain. Yes. Basically, you can always express this by going from one dimension and adding a dimension, then like, because this is basically two-dimensional, like it's on a line, a straight line. And then, or sorry, this is basically one dimension, like on a straight line. And then this is basically two-dimensional, right? Like if you turn here, there might be a different mountain or a different way or whatever. Like, so yeah. I think this is something that we have to be careful of. So just kind of put that out there. Like generally speaking, understand that adding things doesn't make things faster, although it might make you faster. But sometimes also that change of abstraction actually has mechanical benefits. So, okay. Yeah, I remember this week was just kind of brutal. Um, just like reading some of the stuff, like Vanilla JS is by far the most sensible thing to build your web app in. The mild discovery manual documentation absolutely pales in comparison to the endless grind of transitive dependency tooling and updates. I will die on this hill. Front-end Emperor has no close. I mean, sorry, Dev, I didn't end up highlighting your thing for the last one, but I think you're the one. Like, if you go down this thread at some point, maybe it's your quote tweet, Dev. I remember the guy basically said he doesn't build anything that's like not like a blog site, like nothing that's an actual app. So, like, it's fine, but these things kind of blow up because it's really sensational right now. I get the regression. People are sick of having to deal with stuff, but it's not like they're offering a solution that actually solves a problem. So it's kind of like, let's say people have been saying this for all the mainstream frameworks out more than a decade ago. Any sweeping statements like this are likely wrong. It's very wide spectrum what people consider web apps. Frameworks can help build most of them, but overkill for simple cases. Vanilla.js can help simple cases, but maintenance nightmare for complex ones. People talk past each other because they only refer parts of the spectrum they build when they use a web app. And this talking past each other really became, yes, Dev. This is what I was looking for. Thank you. This talking past each other is really kind of need high performance disk and skill one lever. Fully agreed. Building a completely custom low level solution levels to be more important. Frameworks do this for the other 90%. Yeah. This wasn't the one I was looking for, but it's fine. It's just like, we've gone in a really weird state. I actually picked a topic that people often talk past each other with. I was kind of curious, like, people always talk about framework churn, right? And I'm like, how most people experienced it at different points of the time. This went up to 80%. Other times it was, it's kind of hovered around 70. The funny thing is reading all the comments and stories here. There's a bunch of the AngularJS crowd. I get it. That was a hard migration, but a lot of this actually is related to churn within the framework itself. Like, people outside of React or who use React casually think React has changed like a ton over the years, and it kind of has, even though it's still React and it's backwards compatible. Whereas I mean, AngularJS to Angular 2 was a bigger change, but still, like, generally speaking, most of the complaints were actually about existing frameworks updating, and like the other 70%, I'm gathering, are React developers in denial. I mean, the truth is that it's not actually that bad. That it's not. Yeah, AngularJS to Angular is considerably different, but people are like, is React with hooks the same as React before React with hooks? Like, every component library in the ecosystem basically rewrote itself. And it's like, yeah, you know what I mean? Like, I actually think it's because a lot of cases the pain isn't that bad. People generally complain, but the funniest thing is both the people who are kind of anti-React and the React group agree with this statement, because they're like, oh, well, yeah, too many different frameworks. We should just keep on using React. And the other group is like, God, everything just keeps on changing in front end. We shouldn't use JavaScript. So somehow the two biggest groups have actually talked past each other and completely come to agreement on something. And that's kind of crazy, because it means that the only thing you could be doing that's not correct or that's wrong is actually giving smaller frameworks a try, which is kind of an unfortunate reality of things. But it's funny, it wasn't until I saw all the comments that it clicked on me that, like, both of these things, like, people even in this thing are talking past each other, right? There's like we still have that division between the web app and the website part of the world, so to speak. Sweet. Okay. Let's, before that, let me see here. Why did I? No, we talked about this. Talked about that. Actually, good. We don't have it. Okay. Yeah. One more Ryan Florence tweet, but before we do that, let's just do some quick, solid news. What do we got here? I don't know. This is cool. He's been doing a lot of form work. I don't know enough about the UX, but I'm loving seeing Fabian's work. It's very small. It's very tight. It's kind of got that Preact mentality behind it. Valibot is super small and efficient. I'm hoping. I always love seeing another form library installed, so that's pretty sweet. What do we got here? AI PDF summarizer. Nice, another project. Okay, so just only a couple things to highlight this week on Solid. Okay, last two topics. Matt Pocock. Honestly, I don't understand stuff until I can see it in the grid like this. That's why I love drawing grids like this. This finally makes sense to me. It explains why I don't like vibe coding. It's like the exact opposite of where I think a developer coming into AI probably naturally wants to sit. I think it's interesting is that I saw another tweet of this, which basically drew this as a circle where like someone comes in, they're like, yay, AI, I'm now a developer, comes down here and realizes they actually have to learn how to code. And then like comes down here and learns that they have to actually like learn the language to actually be able to describe how the code, like it's a specific language, it's not just plain English. And then eventually gets proficient enough to get up here, like as a loop. It's obviously people enter. I think most developers and people who follow on Twitter probably are going to be down here and idealize want to get up here somewhere from a developer standpoint. In any case, I love this graph. At least finally gives me a spectrum to work with. So yeah, I mean, that's cool. I just want to give it a shout out. All right. What's this Ryan Florence tweet? Sorry, components are awesome, but not enough. Hooks are composable, but awkward. Okay. Signals are novel, but awkward for the same reason. They're novel. See, again, just slight dismissive, but okay. Requiring an execution context. What if we didn't track dependencies? What if better state primitives aren't what we actually need? Okay. I mean, these are questions that obviously anyone who's designed a framework or worked in framework has asked themselves. Yeah, I mean, yeah, I think he's just like looking at the general solution space and finding a way to diss every existing solution or say that there's a problem with every existing solution to open space for saying that we need to find a better solution. He doesn't or hasn't presented at all what a better solution would look like. But let's take this at face value and assume that he isn't just trying to put everything else down and that he's let's do the mental exercise of where this thinking gets us, right? HTMX, maybe. Yeah, I'm saying let's assume that he isn't just doing fluff marketing for Remix. Want whatever he's smoking. Yeah, I mean, it seems like pretty powerful stuff. Well, I mean, maybe that's the answer, right? Like, don't assume like basically HTMX is like bad React, right? It's like, what if we just re-rendered everything and then just like didn't care about how terrible the performance was, right? That would be simple. Components are awesome, but not enough. But that doesn't talk to composition. or like building things. Signals are novel. Yeah, but I mean, if you go, basically, like, are you with me? If you throw away execution context, like locality in general, because I mean, components are execution context, right? Right? Like components don't track. They say all are dependent things are dependencies. But if you're like, what would it look like to throw that all away? Basically, is there a way that we could legitimately do this? Yeah, just wrapping up kisses. I see it. Um, what if people in the elements? I don't know what he's talking about. Okay, signals. Oh, here's an instance. This it's our guy again. I think signals, hooks, and components all solve symptoms. Tell me more. Data flow and unclear ownership. Okay, so how do we solve it? Oh, state machines. Okay. But the problem is state machines, as we already talked about on the thing, that's great for navigating stuff. But then how do you actually synchronize the state at the end? The state is granular or not granular. You're either HTMXing it, VDOMing it, dirty checking it, signals it. Like it doesn't, it higher level architecture saves you, but doesn't actually solve the problem in a real way. Imagine a state machine that included all the dominoes. Oh, maybe you're onto something. Yeah, relying on the server 100%. But okay, but you like these problems are inherent to state, right? Like let's say we rely on the server 100%, like we have like a WebSockets thing. You're just pushing the state issues onto the server, right? Like it's perfectly fine. I think LiveView is a great model, for example, but like you're still going to need to structurally organize stuff and handle composition. You know, the complexity comes with state in the lifetime of the thing, not the where it happens. Yeah, I mean, I think you guys on the stream are just too understand this stuff, right? Too well. Um, okay, so let's keep on going. Like, are we getting any help here? New framework incoming. Lol. Yeah, definitely lol. I'll skip over me. What if there's signals alternate that didn't rely on execution content for tracking ownership disposal? But I mean, explicit versus implicit makes a difference, but I don't think that's what he's saying. Signals aren't novel; they're just a way to Claude doesn't care. Maybe the real problem is we're trying to make state feel magical when it should be explicit and boring. Sometimes the best stretch is minimal, no abstraction. Okay. Sure, but did you have an answer here? Oh, atomic reference. Okay, here's one. Surprisingly, the first closure script in this thread, single atomic reference to immutable value for each screen on UI. That's the architecture. But they're laughing. It's like Redux. Okay. Cook. RxJS. Same problem. Wrong way to think about signals. Well, that's correct. I mean, this is great engagement bait. People are saying a ton of stuff. State parallel to UI. Why not call out the HTMXCO directly? I'm just like reading this. Immediate mode. Oh, here we go. I use my own framework. It says immediate mode API. It exposes a request render re-render function. It's foolproof. I bet you it's super slow too, but let's keep on going. Welcome to Angular. What makes signals awkward? He's going the hypermedia way. I think you guys are right, honestly. The guys who point out HTMX, I think that's the gist of it. He's basically giving up on most performance type things for simplicity, which is a reasonable place to be. People, if you look at the response, people have had enough of the complexity that comes with making stuff that's actually good. They're like, screw it, I don't care. It's fast enough. That's what I'm saying. Remix Stream might be the fast enough framework. They might carry that as a banner. You guys think I'm joking, but like I'm sort of not. Anyways, what I said, this is inspiration for Zone.js and Angular, most Angular classic designs. That being said, execution context is extremely valuable to avoid executing everything, whether that be a component, primitive, DOM binding, whatever. A complete immediate mode render would be a cool way to approach this, but given the DOM is retained mode, even the biggest proponents have generally made concessions due to performance. The VDOM is an incredible development in this direction considering the physics of things. It's true. As I said earlier, React's a thing that should have never worked, yet it works. This is an amazing accomplishment. You know, kind of like, you know, like whenever I see stuff like that, like even just it existing is something to celebrate. But that is probably not it, since you're talking about removing layers, right? He said he wants to remove layers. So I doubt he's actually going to go completely immediate mode. That means we're dealing with retain mode probably, which leads to all the state synchronization concerns with scaling that leads to other solutions. Basically, the DOM has execution context, right? I'm basically saying like the problem is the DOM itself basically forces you into execution context. Like even if you had like an event system or XState, like eventually you're going to have to scope that. Unless you're talking about rendering to canvas, that's pretty interesting. So I made a joke, obviously, at the end. I don't think they're going to canvas, but literally, that is one way that they could definitely change the physics here, because I don't think this is actually solvable, like completely. I think the reality is they're going to pretend it's not a problem and then wonder why people aren't jumping on. Right. I mean, to be fair, it's kind of like the loaders action thing. They could get really far in Remix with that, but a lot of people never picked up Remix simply because they were like, this isn't sufficient for the types of apps I build. I think they're going even further on the extreme there, which is good. I think there's a whole market of people who aren't React. I wonder if Remix is just going to go head to head with Astro, right? But it's weird because you got all of the people who are like Remix React devs of kind of reading this and going, what the hell are you talking about? I think we might be in for like a grown moment. You know what I mean? Where we're just like, oh, that's what he means. Oh, okay. Let's see. Did anyone respond to me? Canvas the next frontier. I mean, if you want to rebuild a bunch of stuff. Some people didn't like that comment. Isn't that Flutter? Yes. Angular. Never. Yeah, what was this? Yeah, Yukino. Yeah. That's because the dominative, like there are abstractions of the DOM and other things, so you can do like native rendering and like native script. It's just enough DOM mirrors. So yes, there is. I don't mean the entire web, but I mean there's the huge amount of work into standardizing and stabilizing the DOM APIs that you kind of give away by going to Canvas. Maybe, like, who knows, maybe things do go there, but it feels like that having that shared standard is what like makes the web attractive, and you're kind of giving up on that. I don't know. I was only joking about the Canvas thing, but you know, here we are. Let me switch around here. Greg wrote something a little while ago. I want to finish up on this note, I think. To be sincere, I'm on vacation in the same place I spent 2-week binge watching your old videos 3 years ago when starting on Leptos. Thanks for your years of teaching. You're such a gift to the world. To date, that stream I did with Greg is my most watched video. It is an amazing stream. Greg is creator of Leptos, is an amazing teacher. That's why I think that stream's so popular. He knew how to teach myself and JavaScript developers how to appreciate Rust, which I don't know, maybe a lot of people are interested, but he made it very accessible, which is incredible. Which is why to this date, every week I look at my numbers, this stream is just the stream that keeps on giving. So it was honestly, thank you for that. My stuff's a little bit, R&D ish. I wish I was a better teacher, honestly, but I do appreciate the compliment. And yeah, that's crazy. Yeah, like I'm glad that knowledge is out there. This is how you inspire the next generation of framework authors, and you're a big part of this. I think pushing the boundaries like this is really important, and I'm glad to know you and to have you know what's this pushed it along, sort of. What's the term? Play it forward. Yeah. Now I'm just catching up with the rest of chat. I was forced to pick up Remix because of Shopify. I don't really enjoy Remix that much, especially flat file routing. Flat routing is cool. I thought it was novel. I had some concerns, but like inconsistency of it. But I think it's actually one of the better solutions for FS routing. Canvas is terrible for accessibility. Yep. Thanks, Greg. Yeah, a lot of thank you, Gregs. There's lots of fast browsing frameworks. Now you're baiting. Uh, but yeah, that stream is amazing because you actually understand why the constraints are of WASM and like how it impacts the different framework stuff, and it pushed the envelope. I think WASM frameworks had kind of got stuck for a while because they were like, yeah, after like I guess it was Sycamore and then Lepto showed you go even faster. Then we got Dioxys doing block on. Like it started pushing like once really understood that overhead. Anyway, thank you all for joining my stream today. I think we're going to call it a stream. You guys have a great one.